Hello, everyone. Welcome to this brand new series of algorithms using Python. In this series, we will learn top 25, 30 algorithms that are highly used in programming and that are asked in the interview questions of big tech giants like MAANG companies. And MAANG stands for Meta, Amazon, Netflix, Google, Microsoft, etc. So we'll discuss all the algorithms that they ask in their interview questions, and we will implement all those algorithms and see that how they work in Python. So let's just dive into this video, and today we are going to discuss a binary search. So we'll take an array, and that array will be sorted. So that means that we can apply binary search in a sorted array, especially if you want to find an item inside that array. So this is just an example. You can also use this algorithm for, other applications. So what I'll do, I'll just go ahead and create an array called 13, 15, or 12, 15, 16, 18, 20, and 22, and 20, 34. Okay. So suppose this is my array in which I want to find a number, and this is a target that I want to find. Let's say we have 15 here, right? So I'll just go ahead and quickly open up my terminal because we're going to need a calculator. So we'll just use Python for that. Okay. So suppose that this is the number that I want to find inside my array, and you can see that this number is present on the second position, and the index of this number is 1 here. So there is one way that we can find is we can look, I mean, this is an entire array, and our program will iterate through the entire array, and at the end it will tell us whether our target is present in this array or not. We can simply go ahead and say that target in AR. Let's say if this works. I'll simply run this program. Uh, 01. Okay, so it's present, right? So here, this is the way that we can use in operator to look into the array. So it will iterate the entire array, and it will look for this number. But what if we have a very huge array, and we want to find the number from that array? So in that case, this is not going to be an optimal way because it will take a lot of time. Uh, and the time of complexity will increase. What we want to do is to decrease that time, and we want to find an optimal solution uh, with which we can find this target from this array. Right. So for that, what we can do is we can use binary search, which we are going to discuss today. So in this method, what we actually do is we split our array into two portions. So you can just take it from that famous saying that divide and conquer. We will divide this array into two parts, and we will look that in which part our target exists. So what we will do, we will take this number, which is the starting number, and then we will take the ending number. And by using both of these numbers, we will find the midpoint of our array. And then we will compare that midpoint with our target. So if the target is less than that number, so we will suppose our midpoint was 18, right? So this 15 is less than this 18. So we will just ignore this entire side because we don't need that. We know now that our number exists in this area. So what we will do, we will update our ending pointer, and we will take it from 34 to 16. And then we will do again, we will find the midpoint again. And in this case, suppose our midpoint is 15. And if that midpoint becomes equal to target, then we will simply return that midpoint. Now, on the other hand, what if we have a target of 20? That's it. Now, the midpoint is 18, right? Let's take 22 just to simplify things. So our midpoint was 18, right? Now we know that our 22 is greater than 18. So that means it cannot exist in this side of the array. So we will ignore all of it, and we will update this pointer, the starting pointer, from 12 to 20. And then we will repeat the steps and we will find the midpoint. And in that case, it will become 22, suppose. And when the target will become equal to 22, then we will just go ahead and return the midpoint, that is 22. All right, so that's how binary search works. First of all, we will implement this binary search using iterative method, and then we can also implement it using recursive method. So what I'll do, I'll just go ahead and create a function. Let me clear my uh, terminal. Okay, so let's just go ahead and create a function called def, and we can say binary search. Now this function will receive two arguments. The first one will be numbers, and in it we can store our array, and the second one can be target. Right. Now, what we want to do is uh, we want to define two pointers, right? If you remember, we had a starting point and an ending point of the array. I'll just go ahead and simply create another array just so we can uh, mimic what we are doing. Let's say this is it. Let's say this is it. So we have this nums. This will be our nums, and the target will be the number that we want to find. And I mentioned that we will need two pointers. The first one will be a starting pointer, and the second one will be at the end of the array. That will be, in this case, suppose it's 34. So for that, we will just define our starting pointer. It starts from 0, and the ending, or the second pointer, it will be the ending element. So we can simply go ahead and say end is equal to length of nums. Length of nums will give us the entire length of this array, and because we want to go to the index of this number, then we will have to minus from it, minus one from it, right? So now we have two pointers, and what we want to do is just look in this array, and we will do it while start is less than and equals to uh, end. Right, I mean, start, this is a sorted array, right? So the pointer that comes before it should be the lesser one, or at least equals. It should not increase the second pointer. Uh, so that could be the condition that we can apply here. And after that, what we can do is find the midpoint. So let's find the midpoint, and here we can say uh, please add start and end, and then divide 2. And that's how we can find the midpoint. Now, what we want to do is we want to compare our midpoint with our target. So we can say if target is equal to uh, nums of midpoint. So this midpoint is actually the index that we are getting of the midpoint, right? So we want to find the number that is stored against this index. So for that we can say nums skip brackets mid. If that's the case, then simply just return as mid. Because our target has become equals to mid, now we don't have to look further. But what if my target is lesser than a midpoint, or the number that comes in mid? In this case, let's suppose the mid is 20, and let's say my target is 15. So in this case, I have to iterate in this area, and I have to ignore this. So for that, what can I do is just take the pointer from here to here. In this case, we will have starting pointer here and ending pointer here, and the midpoint will be here, and we can deal with this side of the array, and this side of the array will get ignored. So we can say else if target is less than nums dot mid. If that's the case, then simply update your end, your second pointer, and put it before the mid. mid minus 1. So suppose this is the mid, right? So I said that if my 15 is less than the 20, then what we can do is we will take the pointer from 34 to 18. So this is the midpoint, and 18 is present on which position? Mid minus 1 position, right? And if target is better, remember we have defined equal condition, we have defined lesser condition, and the other condition, the only condition that's left is greater than, that the target is greater than nums mid. So we don't have to write the condition, we can simply write else here. So we can say if that's the case, then this time you have to update your starting pointer. Suppose my number was 26. So in this case, this is my midpoint and this is my target, right? So in this case, I have to ignore this side of the array. So I will take my starting index from here to here. So if this is my midpoint, so it will be mid plus 1, right? The next value after the mid. So we can simply say mid plus 1. Now, if all of this is not followed, so that means we don't have a number inside that array. So we can simply just go outside this loop and we can say right return minus 1, and which means that we don't or the number does not exist in the array. But now this is the function that we have created, right? Uh, but we have to call this function, or we have to run this program. And for that, what we can do is we can simply say if name is equal to mean. If that's the case, then what you can do is I will say nums is the array that we just discussed. It could be our array. And what else we need? We need target. Suppose my target is 50. And what I want to do is I want to call my binary search. I will simply just go here and complete this word, and this is a binary search. Now I will give both of these values to my binary search function that I have just created. So I will simply say binary, and inside it I will give my nums and my target. And whatever value this function will return, I can simply go ahead and print that value. I will save this program and I will run this program. So here you can say the program is saying that your number that you were trying to find, that 15, is present on 1th position. And we all know that in array our index always starts from 0. So this is 0 and this is 1. So our program is running absolutely fine. Now let's just utilize this minus 1. For example, let's say I have 16 here. Now 16 is not present in this array, right? Now we have to utilize this minus 1. If I just simply go here and save this program, you can see it's giving me minus 1, right? What if I don't want minus 1? Then we can simply use this minus 1 to generate a graceful output. Now, what we can do is we can simply store the value that this function is returning us, that in this case is minus 1, into an index. We can say index or any other value that you want to use, and we can say if index is not equals to minus 1, that means we have the value inside the array. Then simply just print the position of target value in array is, and simply just go ahead and give index. Else else means that your index, the value that your function is returning, is equals to minus 1. Then what will happen then? Then you can simply just go ahead and write the target value is not present in the array. You can save this program and I will run it. And here you can see, because this 16 is not present in my array, the program is returning the target value is not present in array. I will go here and correct the spelling of this word. Now I will just go ahead and change the value. Let's say I'm giving in 26. So I will simply clear this and we will run it. So the position is 5. That means the index is 5. We can say 0, 1, 2, 3, 4, and 5. So that means our function is running absolutely fine. And that's how binary search works in Python. And this is a iterative method. We also have recursive method that we will discuss in the next video. Thank you.